Assalamu alaikum everyone. I hope you're doing okay. So this is our fourth lecture of the semester, and the topic of today's lecture is personal area networks part 2, as we have already covered a few of the topics regarding personal area networks in the last lecture. So in this lecture we're going to learn a little bit about Bluetooth, and then we're going to learn about a few other personal area networks. So the protocol for Bluetooth is, as we've already seen in the previous lecture, is IEEE 802.15.1. So the motivation for creating this standard or this protocol is to provide a universal short-range wireless facility which will allow several users to connect within close proximity with each other and to share a specific amount of data. So this uses the same 2.4 gigahertz bandwidth which is available globally for unlicensed use. So this is the bandwidth which is used by wireless LAN as well as Bluetooth. And if you can remember, there was a separate standard which was 802.15.2 which managed the coexistence between Bluetooth and wireless LAN. So two devices can share up to 720 kilobytes per second according to this standard initially. So we have already seen its uses. Some are wireless headsets which many people use, and then wireless keyboards are also there, Bluetooth keyboards, but the printers are not so common comparatively. And wireless connection to some home appliances are also available in various smart homes, for example connection to ACs, ovens, and even lights. So someone can just sit on the couch or maybe on the bed and control all the things in his home wirelessly. So this architecture can accommodate multiple users simultaneously, which allows the use of multiple appliances together, and even many people can connect to each other using Bluetooth simultaneously as well. So up to 8 devices can form a small network in Bluetooth, and this small network is actually called a piconet. 10 smaller networks or piconets together can coexist in the same Bluetooth radio coverage range. Okay, so this means if 10 small piconets are together in the same space, it will not create much of a problem. The links are encoded and protected, obviously, so there's some amount of privacy, but it doesn't require a higher level of encoding or encryption, because as the range is small, it has lesser chance to be eavesdropped or maybe tapped into by other third-party members physically. So its applications include data and voice transmissions. Example, audio devices, like as we have seen, the headsets that we use, they actually transfer data and voice messages between the device and the, let's say, host computer. So wireless and cableless environment, this is another application, because for a small range, for example for 10 meters of range, if you connect to everything within that range using wires, then it would create a huge amount of cable and a messy environment. So a wireless or cableless environment provides the mobility, and let's say it also is very comfortable to use, and the range can also be extended to 100 meters using amplifiers. And the third application is as the connections are ad hoc, they can be formed very easily, so nodes can join and leave whenever they want. So this is one of the more generic facilities or advantages of personal area networks. So the standard specification or the standard documentation is huge for Bluetooth, which is about, I think, 1,500 pages of documentation, but it's mainly divided into two specifications. The first one is core specifications and the second one is profile specifications. So the core specifications describe the details of the various layers of the architecture, starting from the radio interface to the link control. So the radio interface is in the physical layer, and the link control is somewhere in the data link layer, between the data link layer and the network layer, you could say. So it's sort of like a middleware layer. We're going to see more about it later on. The profile specifications are concerned with the use of Bluetooth technology to support various applications. So it's usually on the application layer, and it determines what settings or what profiles is required to use the Bluetooth device, or what sort of applications and how those applications will be using the device. So Bluetooth is a layered protocol architecture, and it contains the following 4 things, as you can already see. The first one is the core protocols, which forms a 5-layer stack. Okay, so these are the protocols which mainly define how Bluetooth works, and these are all the new protocols that Bluetooth brought forth. The second one is a cable replacement protocol, which is basically just RF COM or radio frequency communication. And the third one is telephony control protocols. We're going to see all of them in details a few seconds later. And the fourth one is adopted protocol. So this basically means all the protocols that Bluetooth has adopted, the protocols which are already existing. So the core protocols form a 5-layer stack, and these are the stacks. We'll go through each of them one by one. The first one is the radio layer, which specifies how the medium will be used and how much more efficiently the radio will be used. For example, it specifies things like which frequency will be used and the modulation techniques, so these sort of things. The second one is the baseband layer. So the baseband layer deals with connection with a piconet. Okay, that means, for example, if you are inside a piconet and you are communicating with, let's say, the master of the piconet. So we're going to learn about master and slave later on, but let's say you're just communicating with a node in a piconet. So the baseband layer determines the size of the frame and the contents of the frame and the timing of the frame as well. So when will the frame be sent, and it also is concerned with addressing. So whenever you're sending the message to a device, what address will that device be representing itself by, and the power control also. So the amount of power that you'll be using when you are sending a signal or receiving a signal. So the link manager protocol, or LMP, is concerned with linking between devices. So it's not the same as baseband. The baseband is more related to the physical layer, while the link manager protocol is related to the data link layer, and it deals with the authentication and encryption of the messages that are being used to communicate. The fourth one is logical link control and adaptation protocol, and in short it can be called L2CAP. So this layer deals with adaptation between inter-layer frames. For example, once you see the protocol architecture, you will see that there's a lot of communication between the layers. So the L2CAP deals with those things and deals with the changing and frames which are related to both the layers. So L2CAP also provides connectionless and connection-oriented services. The fifth one is service discovery protocol. So this is sort of like a protocol to determine what the services different devices can provide and what are the characteristics of different devices. So this protocol sort of queries into the device to learn the different characteristics and properties of that device. So RF COM, or radio frequency communication, as we've already seen before, is the cable replacement protocol. So this protocol virtualizes the cable replacement and makes it more transparent. So what does this mean? Whenever you're virtualizing something, it means that you're making most of the things abstract, so that the user does not have to deal with a lot of the specifications or most of the specifications. So RF COM enables serial port cable changes with minimum modification of devices. So this means that instead of a user, this provides an abstraction to the device. Okay, so whenever you're using a Bluetooth module for a host system, for example, let's say in case of our personal computers, whenever you're using a Bluetooth module, and when we're changing that module and installing another module, so this requires the changing of a lot of you can say connections, and it also depends on what module you'll be using. So RF COM enables this change with less difficulty. The next is TCS bin, which is telephony control specification, and bin for binary. So this defines the calls between the devices. So it manages the mobility of devices as well. For example, whenever two Bluetooth devices are communicating with each other, and let's say is in a call with each other, and both of them are moving, some sort of a manager needs to be there which handles all the changes, and that is done by TCS bin. Okay, so it also manages when groups of devices communicate together. And the last thing is the adopted protocols. So this is just the adoption of different kinds of protocols which are used to avoid reinventing the wheel, because there are many protocols which are defined in a lot of networks, for example in WLAN, and then maybe in other personal area networks. So instead of creating those protocols again, Bluetooth makes efficient use of those protocols which are already existing. So these are some examples of the adopted protocols. The first one is point-to-point protocol, which is for transporting IP datagrams. You should have already learned this. This is PPP. So point-to-point link means end-to-destination communication, and the datagram which is used to send data from one source to destination, that's basically point-to-point protocol. Okay, the protocol which determines this. The next is TCP, UDP, and IP. These are all well-known foundation protocols for the TCP/IP protocol suite, and you have already learned it, so I'm not going to go into it in details. The next is OBEX, or Object Exchange Protocol, which provides, let's say, object exchange, and it's actually a simpler version of HTTP, but OBEX is much more easier to use compared to HTTP, because Bluetooth devices tend to be much more smaller compared to PCs and other devices which can use HTTP to its fullest extent. And some examples of the objects that are transferred include vCard and vCalendar, and you can look them up also in the book. The last one is WAE, which is Wireless Application Environment, or WAP, which is Wireless Application Protocol, and these two protocols are also very well known, so I'm not going to go into it in details. So this is a figure of the Bluetooth architecture, and okay, this requires a bit of explanation, so I'm going to explain it a little bit. So what you have seen till now, the radio part, right? So this is the radio part, and this is the baseband part. So as you can see, there is a two-headed arrow sign which indicates communication between the radio interface and the baseband control. So this means actually there is a difference between the top part and the bottom part of the lower layer stack. So the bottom part of the entire, let's say, host controller, link manager, voice codec, and baseband controller, radio interface, etc. This entire thing is the lower layer stack, which is actually part of the Bluetooth module. Okay, so this Bluetooth module can be removed from the system, and another Bluetooth module can be attached also. And the upper part is the upper layer stack, which is part of the host system, or let's say the host PC, you can call it. Okay, so the application layer and the different, let's say, SDP, L2CAP, then different access protocols. So this access protocol means the adopted protocol, so it can be IP, UDP, as you've already seen before, and then the host controller interface, which communicates with the Bluetooth module. So there's a host controller in the Bluetooth module as well. Okay, and in the middle, this is what we call HCI, or the host controller interface. So the Bluetooth module communicates with the host system using the host controller, and the baseband controller, we have already explained the baseband controller, then the radio interface, and the video voice codec is new. So this is actually used to communicate using analog audio, or to communicate using audio, you can say in simple. So there is a clear distinction between the physical layer and the data link layer, as you can see here, the radio interface and the baseband control. But and also the application layer is quite different from the network layer, but the network layer and the data link layer is sort of mixed here, and it's in entirety it's called a middleware layer. Okay, so let's see how the architecture works. A little recap. So the unit of Bluetooth is a piconet, as we have already seen, and the total of 8 nodes are present in a piconet or a network, and only one of those 8 acts as a master, and the rest 7 work as a slave. Okay, so the master determines the time channel, that means the time when a message will be sent and using which frequency or which channel. So this the method or technique which it uses is frequency hop spread spectrum. Okay, so I think you have already learned this, but still I'm going to give a small brief description of how FHSS works. Okay, so it usually uses a broader range of frequency channels and randomly selects one channel to communicate, and then after a message is sent, it or after a set period of time, it quickly shifts or changes the channel to a new one. Okay, so it keeps changing the channel after a specific period of time, so that it cannot be understood which channel is currently being used. Okay, so this sort of provides an encryption, or you can call it, this provides a sort of like a security. Okay, so this FHSS is used when the master communicates, or even when the other slaves communicate with the master, and the hop or the frequency which is currently being used is determined by the master. The other 7 slaves only join the channel and the phase which is determined by the master. So a device can simultaneously be part of 2 piconets. Okay, so that as we've already seen, I think 10 networks or piconets can exist together at the same space. Okay, so this overlapping structure of different piconets is called a scatternet, and this structure of a piconet or a scatternet allows efficient use of resources, because many devices can then communicate using the same space or the same bandwidth. Okay, so 8 devices, that means 1 piconet, shares 1 megahertz bandwidth, which is a single channel to communicate, and a maximum of 80 megahertz can be shared in this way using frequency hopping. So this means that, let's say there are 80 megahertz, and out of those 80 megahertz, a master can select any 1 megahertz of the 80 megahertz and communicate. Okay, and then after a set period of time, choose another 1 megahertz channel within those 80 megahertz. Okay, so using frequency hopping, a maximum of 80 megahertz can be used. And if you can guess, then if 10 piconets combinedly try to use the 80 megahertz bandwidth, then some collisions might occur. Okay, and that's true, some collisions do occur. So this is a figure of the master-slave relationship. So if you can see here, so this is the M is the master and S is the slave. Okay, and M/S, this means that this node acts as a master and also as a slave. So it acts as a slave for this network, and it acts as a master for this network. Okay, so this is how an overlapping structure looks like. Okay, so these are some examples of wireless network configurations which show the comparison between Bluetooth networks and other networks. So at the very top left, the cellular system, which uses a sort of like a hexagonal structure for each of the cells, and at the center, the square, what you see as the square is the BTS tower, and the circles surrounding it are the mobile devices which are using that network. Okay, so this is how the cellular system looks like. And then the second part, which is B, figure B, which represents the conventional ad hoc systems. Okay, so as you can see, there is clearly no structure of the ad hoc systems, and those two smaller the smaller circles that you see are the nodes, and the dotted line is a network. Okay, so there are 2 networks shown in this figure, and in the last figure, which is C, we can see it's a scatternet. Okay, so here you can see that the networks or piconets are actually overlapping. Compared to this, the other 2 networks, A and B, there are no overlapping spaces, because they need the entire bandwidth to communicate with each other. But in case of scatternets, that's not the case. Okay, because they are using frequency hop spread spectrum, many piconets can actually coexist in the same space or same range. So next we are going to see 802.15.6, which is body area networks, or in short it's called BAN. Okay, so WBAN or wireless BAN is mainly used for consumer applications. Okay, the examples are monitoring the health condition of a normal or healthy person, that means someone without a disease. For example, Samsung, I think, already has an application which reads the temperature, or maybe the calorie burned or the calorie used in the body. But the body area networks usually means that there are sensors placed throughout the body which take readings. And another example can be checking the vital parameters of patients with chronic diseases like diabetes, asthma, and heart attacks. So these are patients which are sick throughout their lifetime. So checking their vital parameters, their conditions, for example, in case of diabetes, whether the sugar is high or low, things like that are checked using body area networks. And the third use is in hospitals, sports, military or security purposes. For example, in hospitals, it can be used to monitor a critically ill patient and to let the doctor know immediately when something occurs or whether the patient is in danger or not. And in sports, it might be used to monitor the body of an athlete when, let's say, he's performing some exercise. And in military, it might be deployed in a camp to monitor the activities of a soldier when he's in training. Or it might also be deployed for security purposes to monitor, let's say, a prisoner. So in places like that, a wireless band can be used. It's also called a body sensor network, or BSN, as it's also a sensor network, because to sense the different parameters of the body, you need a sensor. And as it's mainly used for medical purposes, it's also called a medical body area network, or M-band. So the network consists of several miniaturized body sensor units, or BSUs. Obviously, without any sensor, you cannot sense anything actually. But it may also contain a smart interface, for example, a smartwatch which shows your heartbeat, or for example, the Apple Watch maybe. It might also be a pocket device which may be kept in the pocket, and then it can be taken out to see the condition of the network, and so on. So these are some of the characteristics or continuing characteristics of band. So the device may be surface mounted, for example, the watch, that's actually a surface mounted device, or it may be implanted inside the body. Okay, so this is rare, but it might be required in some cases. And the device or interface can be carried in pockets or in handheld bags, and the devices must be low power, short range, wireless, and extremely reliable. So it needs to be low power because it has to be battery powered, as it will be carried in the body, and it has to be short range so that it does not interfere with any other networks in the area, and basically because your body is not a huge range, so the short range suffices. Then it has to be wireless, otherwise your whole body will be, let's say, covered with wires. And it has to be extremely reliable, because most of the cases body area networks are used to monitor the health and for medical issues. So it is very important that the network is reliable and you get the data that you need instantly and without failure. So the bands that the body area network uses is the industrial scientific medical bands, or ISM, which is given for medical uses by a central authority, and also the frequency bands which the local area networks use. So it can support quality of service as well, and has a data rate of 10 megabits per second. So it can include various portable antenna depending on the person's body. For example, if the person is fat, thin, male or female, etc. So depending on these scenarios, the antenna might change. So why does it change? So that the body radiation absorption, that means the amount of radiation that the body absorbs, it might be harmful for the body as well. So the amount of radiation that the body absorbs, if that can be reduced, that's one benefit. And again, if less radiation is absorbed by the body, that means there's less interference in the network, and the communication is much more reliable and more accurate. So considering these things, there might be an antenna connected to the device, and the antenna might be of different shapes or sizes, or of different technologies depending on the scenario. So it can contain sensors to monitor vital signs and physiological changes of the body, and it can also contain motion detectors or accelerometers, which are present in some of our mobile phones as well. And obviously it needs to contain some sort of device which can communicate with other sensors or other devices which are in the body area network. So the basic components of a device present in a body area network are sensors depending on what it is sensing. For example, it might be a motion detector, or a sensor to detect the vital signs, as we have already seen before. And it will obviously contain a processor to perform the calculations, and it needs a transceiver so that it can send and receive message. and it needs a battery because it's a low power device, so it needs it needs a long battery life, so that the battery life doesn't extinguish in the middle of, let's say, an important procedure. So the interface can be a PDA or personal digital assistant, or it can also be a body so a body sensor network interface may also be present. So this is an example of a body area network application. So as you can see, this network has an ECG sensor, a blood pressure sensor, insulin pump, EMG sensor, motion sensor. So these are all situated or distributed throughout the body, and there's a control unit, which in this case is a smartphone, and this control unit communicates with an access point through Wi-Fi, or maybe using data which is 3G or 4G, and communicates with the base station to send the information using the internet. Okay, so this can be considered an example in case of a healthy human being, or also it can be considered an example for a person with medical illness or chronic diseases. So that was about it regarding body area networks. So next we're just going to see in brief about LoWPAN, or low power wireless personal area networks, which is also a variation of personal area networks and has many applications. So 6 LoWPAN, which is let's say used in local area local area networks. So this applies PAN using IoT devices and the internet. So it uses different mechanisms to send IPv6 packets, which is why the name is actually 6 LoWPAN. So it can send packets just like IPv6 packets, just like local area networks, metropolitan area networks, and wide area networks. So this is used as a micromanagement. For example, in many of the homes, there are smart billing systems which automatically take the reading of, let's say, the electricity consumption or the water consumption, or maybe some other sort of consumption. So those smart grids are examples of 6 LoWPAN application. Then there are also home automation uses, for example, in smart homes. So they can be used to actually control or monitor different devices in homes. So LoWPAN can also be used in Android mobile phones using an API, and it can be used to join a low power wireless mesh network. So as you can use a LoWPAN to send IPv6 packets, but it's different than the LAN, MAN, and WAN because it has lower power consumption and it also has a lower signal power. So it can be used to connect to a secret network as well. For example, if you have seen the series Person of Interest, season 4 episode 1, they use the mobile phone to connect to a mesh network, which actually uses the cables or wireless antennas in the television sets, and uses that network to communicate secretly without the government being able to detect that network. Okay, so LoWPAN can be used to connect to different wireless mesh networks without being detected as well. So that was about it, and these were the references that I followed, or the references that I used. So the second reference is the book that I've already given to you, but the rest are basically just links and is available to everyone. So if you have any questions, obviously you can ask me in YouTube, Google Classroom, or Kubul as well. So that's about it, and with this I'm going to end this lecture. Assalamu alaikum everyone.